Microphone check. 1 2 1 2. We are live. Yeah. Monday training session, February 26th. That's what's up. Mondays, Wednesdays, and Saturdays is the contest day. Everybody knows that. I'm just chill for a minute. Make sure everything is set up. All right. All right. Are we ready to party? What are y'all saying? I'm ready. I am ready. It's LeetCode.com. Daily problem time. Diameter of a binary tree. Already done it. Should I do it again? How does this work? Given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. I guess I'm going to try and just DFS this or something. Man, where's my chat at? I see the game warden. What's happening? 7 Ajinkia, how you doing? It's already Tuesday here. Oh man, it is Monday here. Asia C Mac in the house. Hello, Asia C Mac. Q Ultimus, how you doing, Q? Welcome to the training sesh. All right, we gotta do this easy daily problem. So I guess I'm just going to DFS, visit every node, and I need the path from the left side to the leaf, the right side to the leaf, and like add them up or something, and add 1. Let's see if I can do that. Well, it's a little lighter, but not too bad. Oh yeah, Q. I'm so sorry. I'm so sorry I let you down, man. I really tried. I think you would have been rich if I didn't mess up. I think I messed up big time on Q2. We're talking about the contest, by the way. The last contest, weekly contest, 386 maybe. So Q bet big bucks that my rating was gonna go up. So many people bet big bucks, and somebody bet big bucks my rating's gonna go down, and my rating went down by about 5. And I think I just spent way too much time on Q2. Conceptually I knew what to do, but implementing it was not the greatest. And I was so mad at myself, man, because that's something that I should know how to do. And I just struggled. I don't know why I struggled, but I struggled until I started to just... I should have done this from the beginning, was just treat it like intervals. Like 2 separate intervals. And then when I did those intervals trick, it worked. But I was trying to like do a bunch of if statements to figure out if they overlapped and all that junk. But then I just use the mins of something and the maxes of something, and then that's how I checked if they overlap. I did it virtually 1 out of 4. Definitely should have gotten 2. Just stayed on Q2 and didn't try looking at Q3. Q3 was tough too, man. I spent a long time on Q3 and I could not come up with a working solution. Although I think I was close. But after the contest, I realized that I was completely off course, man. I don't think I would have gotten Q3 if I had stayed down that path. I think I needed to do... Q3 was basically like a cocoa eating bananas type of problem. Anyways, you win some, you lose some. It is what it is. But Q, don't go making big crazy bets, man. You might lose all your money. What else? Alright, wait. Good, still mostly rich. That's good to know. Alright, so let me try and do this thing. So if this doesn't exist, then we return 0, because that means we are out of bounds. We need the left side. We need the right side. So how do we get up there? And then what do we return? What are we looking for? We need... I'm going to pass an answer down by reference. So left plus right plus 1, I guess. And left plus right plus 1. Let me get my pen out. I'm trying to like explain more than I normally do, because I think people are like watching the YouTube videos, man. At least a little bit. So left means like if we're at, dang, hold up. If we're at this current node, the left side would be like this. So that's a length of 2. And this right, or is that 2? 3 is the length of the path. Oh, they want, yeah, so maybe I don't need this plus 1 then. It's just left plus right. Maybe, I don't know. And then this would be the right side. It just goes on 1. So that's what I'm trying to find. So for here, left would just be 1 and right would just be 1. And like for 5, left would be 0, because here it goes to a null node and we have if not root return 0. So both things would be 0 there. Anyways, and what do we return? We want to return the longest of left or right, I suppose. And then here we record the answer. Shandu 16, what's happening? Welcome to the party. All right, let me see if that works. I have a feeling. Oh wait, I have a feeling that's wrong. Maybe I have to do return 1 plus left or right. Otherwise it will always be 0. It would never increment. So here I'm like adding on that node to the edge or something like that. Let us see what's poppin'. Oh man. Dang, so many typos, man. Still doing algos and stuff. Looks like he got addicted. I suppose I have the traits of a crackhead, man. I'm a LeetCode crackhead, basically. Yeah. I'm still doing algos, and I don't know. I know why. It's because it's kind of fun, and it helps me stay sharp, even though I haven't needed to do these algos in a long time for any interviews or anything. I still think there's some value in training to keep sharp, you know. I think addicted to algos is not a bad thing. Yeah, I think it's not too bad. Kaffa Dam, thank you very much for the follow. Smart Coder, what's happening? I thought you'd crush the contest. You thought wrong, man. That contest crushed me. Specifically Q2, I think if I had gotten a real time on Q2, no condom Chris, type racer time, I see it. I think if I had finished Q2, how fast I should be able to do it, then I would have gotten a really high rating, maybe. I don't know. Lead coach in the house, what's happening? You can Q3. All right, I'm going to try Q3 right after this type racer. That's what's going to happen right now, man. Y'all ready? Type racer. Oh, we should. Who's here for type racer, man? Let's do a little bet. I mean, I should probably bet against no condom Chris. The whole gang is here. Yeah. Should I give myself 10 WPMs for no condom Chris? Or what? Let's see. What's the bet? Last time I couldn't even come close to 10 WPMs, man. Alright. 14 WPMs handicap for me versus no condom Chris. Who's gonna win? No condom Chris is a very fast typer. I'm gonna say that right now. I am not a very fast typer, but dang, no condom Chris don't play around. 22,222. That's a lot of money. And Lead Coach, what are you doing, man? You're crazy. Q Ultima's trying to take all that money. Smart Coder also trying to take some of that money. But place your bets. We're about to race. It appears no condom Chris is doing some risky bets. You ready? All right, let me create this racetrack. First race, warm up. Second race, championship round. Should I post it on the Discord? Yeah, I think I will. Discord first, then Twitch. Let me post it on YouTube. All you people out there on YouTube, if you want to join in the type racer, you are more than welcome to. Here we go. First race, warm up. Second race, championship round. Looks like a tough warm up, man. Oh, real Raymond Jones. I see you out here. This is just a warm-up, man. Don't trip. Dang, even with the handicap in the warm-up, I would still need more juice. Let me see what those bets are like, man. Oh, Clistar, 5,000 bucks. All right, here we go. Here we go. Championship round. No joking around. Oh, look at that. Look at that. Oh, man. No condom Chris. Back to the streets. So the bet was, well, first of all, no condom Chris won that race if there was no handicap coming in at 104 miles per hour. But there was a 14 WPM handicap on me, which means that we're gonna have to take his money. Take his money. Here we go. Dang. No condom Chris, I'm sorry. But Clistar just got all that money. Q Ultimus a little bit back. Smart Coder. Bebado Arante. Asia C Mac. Cheat? What are you talking about? And welcome Peculiar Shroom. What's up? And Q Destroyer, what's happening? Finally caught a stream. Welcome to the party. Alright, here we go, here we go. I bet on Chris wasn't aware of any handicaps, man. It was in the problem statement. But don't you worry. Only 20 bucks. You get that back in no time. Everything will be alright. Alright, here we go. We're gonna do Q3 on the weekly contest now. Are y'all ready? The weekly contest that just went by. Easy plus 10. Plus 10. Alright, this was Q3. Not many people got it. Oh, plus 10 on the... Oh, man. Good looking out. Hold up. Easy plus 10. There we go. We need those. We need those coins. Good problem for me? Which one? Q3? Yeah. We'll see. Earliest second to mark indices. You're given two one-indexed integer arrays, nums, and change indices, having lengths n and m, respectively. Initially, all indices in nums are unmarked. Your task is to mark all indices in nums. In each second, s, in order from 1 to m, inclusive, you can perform one of the following operations. Choose an index I in range 1 to n and decrement nums I by 1. If nums change indices s is equal to 0, mark the index change indices s or do nothing. Return an integer denoting the earliest second in the range 1 to m when all indices in nums can be marked by choosing operations optimally or -1 if it is impossible. JCast19, welcome to the party. Alright, man, so I tried a whole bunch of things that didn't work during the contest, I'm about to erase it all because I don't think any of it is good. So we're going with a new approach here. We're going to try to... I should have tried to do this on the contest, but I'm going to try and binary search on the answer. We're looking for the earliest second when all indices in nums can be marked. So I guess this is how many seconds that we got. So our binary search, I don't know how to do it yet, but I'm just typing out my template right here. So like my left is gonna be like 0 or something maybe. Should I start with 0? Or should I start with 1? I suppose we should start with 1. And then I'll use my maximum seconds to be M, I guess. Because that's how many seconds we got to do the thing. Yeah, 1 to M. In each second, 1 to M. Trapper 52, what's happened? Hope all is well. Yeah, all is pretty good. So this is my binary search. This is my midpoint. My binary search, I like to do L less than equal to R. Some people do L less than R like that, but I think that's more confusing for me. I also like to keep track of like my best variable or my best guess. So what are we doing here? We need an isValid function. I'll fill in this in a bit. Not sure. And then if it's valid. So this is just all my template, man. This isn't the actual meat of the problem yet. So if it's valid, I need to remember that this is my best possible. But then I also need to move it to bring down the max so that we try a lower second, right? And if it's not valid, we need to try a longer time. And then I just have to create this isValid function to verify that we can do it in that amount of seconds. Peace Bridge, what's happened? Would you say it is helpful to type out your template before thinking about the details of the problem and later modifying it? I don't know if it's super helpful. I'm just doing it because it will help me to like explain maybe what I'm doing a little bit easier if I just have the standard binary search down, and all I'm trying to do is create this isValid function to verify at a particular time we can mark all indices marked on the thing. So that's like, I think this is the actual problem once you realize that binary search can work. So, and I don't know how to solve that yet. So I'm going to make this function here soon. Motive, what's happening? I do L less than H. Hector HSC, thank you very much for the 100 bits. Trapper 52, I'm about to answer your question real quick. Let me put down some diamonds by Hector HSC. Man, hold up. I'm gonna have to go dark for a second, man. I forgot to log into my thing. Hold on, I'm still here. I'm still here. I'm just doing some stuff real quick. All right, we're back. We are back, man. Hector HSC, where you at? Right here. Thank you for those bits. Thank you very much. 3 diamonds turns into 4 diamonds. All right. Trapper52 says, before you started grinding LeetCode, did you have to learn the data structures in C++? For sure. I think I did this around the same time. So I didn't know any C++ when I first started to do LeetCode in 2019. And I decided I'm just going to jump into LeetCode, try it with C++, and I'll just learn as I go along. And I guess it worked out for me because I think the very first thing I did was a contest. And it just made me extra focused, like looking up things in C++. I had to Google everything, like how to append to an array, or how to iterate through an array, how to write a for loop, how to do this, how to do that. I didn't even know anything about priority queues. That name sounded really scary to me, so I didn't learn priority queues until over a year, or almost a year into my studies. And so I guess I didn't actually learn all the data structures, but I just jumped right in, man. Angel from YouTube, what's happened? Very satisfying keyboard. I'm also watching you to learn to get into the LeetCode mindset and understand algorithms. Angel, you are in the right place. The mindset is something that you develop over time. It took me many years to develop my LeetCode mindset, to like have the mental fortitude to like study consistently every day or whatever. Which languages were you using before C++? Right before C++, I was mainly doing like, what was I doing? JavaScript and TypeScript, but not very well. And before these things, I was doing VB.NET, or maybe some Python also. The mindset of understanding failure is how you learn to LeetCode. I guess you have to be okay with, comfortable with failing, because you're gonna fail a lot. Anyways, back to this problem. So I just plopped down my binary search template pretty much, and then we're trying to make this isValid function. So maybe we need to pass down my nums. I'm gonna just call that change because I made so many typos during the contest trying to type this word. All right. Ganesh KTVB from YouTube. What's happening? I can't even understand that question. I almost gave time to just understand that question in the contest. Yeah, I feel you on that, man. This question tripped me up for sure. That keyboard is creamy. What do I got there? Thank you. It's a Bubble 75 with Aqua Kings. All right, how do we know that we can mark these indices by a certain time? That's what we need to figure out right now before I go any further with this question. So we've got some numbers, we got some change indices, and like, let's say the first time this runs, how many things in here? 8. Our mid is going to be 1 plus 9 over 2, which is equal to 5, I think. 9 over 2 is 4. Plus 1 is 5. So our first guess is 5. How can we verify that we can do this in 5 seconds? 876 Blackbeard, thank you very much for the follow. So this answer should be 8. That means we can't do it in 5 seconds. How do we know that it is impossible to do in 5 seconds? Maybe we can say well, we need at least 4 seconds here. So I'd say the absolute minimum that we can mark everything here is 2 plus 2 plus the amount of elements. So that's 7. So maybe that could be one quick way to check if it's even possible within a certain guess. But how do I know if it's possible, if it's within a possible range? How to know that it's possible with this configuration? I don't know that yet. W Subtico, what's happening? How are you doing? I have a junior dev job and I use ChatGPT for almost everything. How do you get unmessed up? I don't know, man. I'd say maybe try to understand what you're using ChatGPT to do. But maybe if you're doing good at work, maybe there is not much you got to do differently. I don't know. Man, is this one too hard? Tariq Williams. What's happened? Am I from your home country? Yes, I am. Yeah, thank you very much, Tariq. Welcome to the party. It's hard for me to turn on my accent in front of the world. But I am from Jamaica for sure. All right, let me think about a right answer. So 8 is a good answer, right? I am uncertain what to do here. Maybe I could just start from index 8 and work my way backwards. Or something. Spoon XOR, thank you very much for that sub. Man, this problem is hard even knowing that the answer is a binary search. Where is my thing? All right, here we go. Oh, this is old. Spoon XOR, you are coming up here on 2024. There you are. Thank you very much, Spoon XOR. You don't even need binary search. You can do linear search. Oh, snap. Wait, hold up, LeetCode. Hold up. I still got to figure out this isValid function, which is probably the meat of the problem. Intuition. How are you doing? I'm the kind of guy who eats the frog first. What? I'm a junior data analysis, and the first thing I started studying was Python. The thing is that now I am regretting my business major and I'm getting in love with developing. That's fine. I don't think you need a CS degree to be a computer scientist or a software engineer. I'm confused what it means to mark an index. I think it just means that you mark it, like put a check next to it, man, or something. Anyways, let me think. So second 8 corresponds to minus, so I guess this. So I wonder if we can just iterate from the back. And then what? So maybe here we'd want to mark, no. I don't know what to do. So this is 2. Let me type these indices up here too. Or something. 0. So here, I guess we can mark that as seen. And then here, we've already seen it, so maybe we want to decrement one of these. But which one do we decrement? We probably want to decrement the one that we have to... Oh, wait. These are all one index. This is another thing with this problem that really was annoying, that they had everything one indexed. So that would have been... Yeah. Let me start over. My bad. So 2, we can't, so we decrement something. 2 again. We can't do anything, so I have to decrement something. Which one do we decrement though? Should I put like 1 index positions up here? I guess 2 comes before 1, so maybe we want to get that to 0 first. What is this, MATLAB? Yeah. Who 1 indexes? LeetCode sometimes, apparently. So here we can mark index 2 as seen because it's 0. But we can also mark it as seen like down the line. So I don't know how to make that decision, you know. So I'll just mark it seen there. Then we're here. It's already marked as seen, so maybe there's only 1 number to decrement. Three, this can be marked as seen. 2, I guess that could be, that's already marked as seen. Decrement that. I don't know, man. This one is too hard for me, I think. I'm graduating this year with chemistry and biochemistry, but I lost interest during second semester and I started to learn C and did CS50 Harvard. I'm currently doing projects in LeetCode with Django. LeetCode with Django. Interesting. I'm so lost on this problem. I thought I was gonna be able to tackle this like easy work, but well, right now my guess is 5. Yeah, so I was trying to see what it would look like to verify that we can mark everything in a certain amount of time, but 5 is not valid, and I'd say one quick way to check is to like do the accumulation plus the number of elements, because you need a minimum of that many. Also 5 is 2 2 2 3. Oh, that's a good observation, no condom Chris. In the first 5 elements, do we see all indices? Okay. And if the first slot is non-zero, then you will never be able to mark it. Don't choose, just save the decrement for when you need it. Don't choose. Noel Codes, what's happening? Welcome to the party. All right, let me think about that. You don't have a 1 to mark the first slot, right? And if the first slot is non-zero, then you'll never be able to mark it. I get what you're saying fully. Okay, so we need to make sure that we see all the indices for sure. So I guess we can iterate from I to guess minus 1 because it's 1 indexed. So this is going to mark, or this is going to tell us like all, hold on. So all right, even if, let me think here, no condom Chris. Even if we had a 1, let's say we had a 1 here or something like this, right? Then this is not possible also, right? Because is it possible? No, we don't have enough time. Because we need 4 free things, right? And then we need 3 moves to mark each index. So I don't know if I'm like confusing myself. If we see all indices, at what time do we mark each index? Right, so if we see all the indices, we want to probably mark them as late as possible. Or something. But oh, you saw that I'm cooking. But now, I guess man, it's still tough. It's still tough for me because you want to mark them as late as possible, but what if you have like a choice to make? All right, let me try and come up with an example. So, all right, let's just say these two are 1, right? Just to make things a little bit easier here. And let's say we have to mark index 2 like by second. Let me put these as 1 index also. So we have to mark this position 2 by the second. And then we have to mark position 1 by the 3rd second. So this should be impossible, because if we're here, we can't mark index 2 because it's not 0 yet. So then we spend 1 turn to make it 0. Then we go to the next one. Now we can mark it as seen. And then we go to the next one, and then we don't have any time to decrement position 1. And that's our like only chance. So I'm trying to think, how can I verify that this is not valid? Kamza, thank you very much for the follow. All right, so maybe we can take the last thing. So like this one would say like index slot 1. The absolute last time that we need to decrement that to 0 is by second 3. Slot 2, that would be 2 seconds. And slot 3 would be 5 seconds. So maybe do I have to like verify that each of these things, like let me reset that back to 1. So how do I verify that, man? That's what I'm confused about right now. Because we could mark slot 1 as seen, but then we can't mark slot 2 as seen. So maybe we have to like add up how many things. If it's your last opportunity to mark a slot, do it. If you can't, return false. So you're saying maybe I'm just overthinking it and I don't need to know that until I just run the course. Well, okay, so I need to sort these in order of, I need some type of priority queue, and I need it to be the last scene. Which order do we decrement? We want to decrement the earliest seconds first. So like this case would be slot 2 because slot 2 comes up the fastest. So I'm guessing I need to make this priority queue each time based on my guess. So unordered, maybe I'll make unordered map. So this is going to map each slot to the seconds it needs to finish by, or last, let me just call it last chance. Oh, this is gonna get weird. Because the off by ones, or the 1 index. So the last chance to mark change I is equal to I. You have 3 options on each iteration, so you're trying to minimize seconds, right? I was thinking priority queue kind of like min max algo. Yeah, I think we need a priority queue for sure. I just unsure how to use it right now. So last chance of that slot is equal. Yeah, so I think this is okay. Maybe this should be like I plus 1. If we want to be, I don't know. I'm not cooking? Wait, what do you mean I'm not cooking? So I'm trying to remember the last chance we have for each slot. And then I want to no priority queue. No priority queue. Is that an absolute no, or is that more like there are other ways to do it? and a priority queue isn't optimal, but it will work. Because if I have my priority queue and I have like my numbers, my positions, say I'm just gonna zip them up, you know, maybe like a I guess I could use a tuple. Zeddy Zill, thank you very much for the follow. Man, this problem is too hard. Talking about it wasn't so bad. LeetCode with the hard truths. Wait, so then how, if we don't have a priority queue, how do we know which one to decrement first? I guess we can just put them in a Alright, so if our last chance looks like this. Man, I'm using a lot of brain juice to solve this one, man. So if our last chance looks like it's basically this, right? Then do we just like sort them? 2, 3, 5. So position 2, this will equal to like 2. Man, how do I represent that? 2, 2. Index 1, value 2, and index slot 3, and the value is 0 or something like that. I always pronounced tuple was pronounced tuple. I don't know how to pronounce that. Tuple, tuple. No condom Chris is for sure a guardian. If I had to estimate, man, I'd say 2,400, 2,500. I don't know. You gotta be lazy. It's like when your mom asks if you've done your homework yet, but you didn't, so you just do it right when she asks you, and then you play a video. What are you talking about, man? Oh, don't decrement beforehand. Just decrement when you're marking an index. Lead coach. I'm not sure what you mean. Don't decrement beforehand. Just decrement when you're marking an index. Let me think about that. Alright, so here we're at 2. This is our last chance to mark index 2 as seen. And we've already, okay, so we're at 2 seconds. That means we have 1 second of spare change because we need the second to mark it as seen. So maybe I have like 3 seconds. So we have 1 free second right now. We can spend that +1 to mark the index and decrement all at the same time. So let's try that. Now we have 0 free seconds. I see. Lead coach. I see what you're saying, man. And then now we have 0 free seconds. We need to mark 1 index. But we can't even decrement it. Because we don't have any free time, man. That story is the allegory of this problem. lazily deciding. Oh, do you get my story now? Oh yeah, I I do get your story now. I'm gonna tell my boss that's what I'm doing tomorrow. Lazily deciding. I've never come across this technique, man, but I think I understand it. So let me get rid of this PIPII thing. I'll keep track of my scenes. And then this is the last chance that we have. So maybe I have to like do one more pass. Alright, so then how do we know 3 seconds? I won't use the word lazy though, I'll just tell him I'm optimizing. Hold on. I gotta actually solve this, man. We've been on this problem a little bit too long. So I guess if man, this is gonna get confusing. I'm just use some variables to make it a little bit easier for me. So that's the slot that we're looking at. So if that slot is not equal to 0, then we can't mark it as seen. So what do we do? Do we increase our 3 seconds in this case? But if it is 0, let me make a new set called marked. How do I do this? We're looking that it's not marked. Jigoku TV. Thank you very much for the follow. I guess we can just put an else here. This can probably be cleaned up, I'm not gonna lie. Jigoku TV, welcome to the party. How are you doing? I think, alright, I think this can be like easier to read if I just did all of that. So if the slot is 0 and we haven't marked it as seen yet, then we should mark it as seen. Otherwise, wait. We need the 3 seconds. Should I do that here? So if 3 seconds is greater than so if we have enough 3 seconds, then we can mark it as seen. Hold on, now it's getting really confusing. Let me just put that there instead. Because, yeah, anyways. Steven Sagiball, what's happening? Contains is in C++20, usable in, no need to type find unless you need the iterator. Right. I've always thought about doing that, but I always forget. Decadent. What's happening? Welcome to the stream. Are you working for Google or some or other big companies? Yeah, I am. How are you doing? Welcome. Has anyone redeemed secret gift? No, secret gift is gonna be one of my pictures. Should I go get one? Let me go get one. Alright, this is the secret gift, man. Maybe one of these photos that I've taken. There it is. I guess I'll just ship that to you or something. Keep on coding. What's happening? Welcome to the party. No, it's not a picture of me, Steven Saggyball. Doesn't look very cheap to print. No, it was like expensive. Double digits. Double digits. Thought secret gift was a keyboard. That is the super secret gift. I'm gonna change these titles because it's not secret anymore. Anyways, I gotta solve this problem, man. So we mark it as that, and then do I have to do that? I don't know. So that's what we're saying. And then we just want to make sure that all the things that we've marked. So in that case, we don't even need to check that scene thing, but I'll leave it there. Man, so nums, change, and guess. Hopefully this works. Nah. I don't know what this is. This is probably like a one index type of off by one thing. So this slot, I'm gonna do -1 maybe. Nah, that ain't right either. It ain't right. Let me think. Where is it going wrong? So this guess should be one indexed. We're passing this one index guess down. Maybe I don't need that -1 in that case. All right, let me try now. 8, 6, no. -1, -1, -1. All right, we gotta do some debugging, man. This problem is kicking my ass. Too many test cases. Let me just go with one test case. So I'm all right. I'm saying 6 is true. That ain't right, man. Oh, that's not true. That's the mark size. So I'm saying at 6 I only marked one thing. Hold on, you're close. Oh yeah. Nah, I think for sure it's a dang problem because of the one indexing. I'm just trying to locate it. So the guess is up to there. I think that's okay. The last chance. Maybe the last chance is... Oh, we only want to mark it on the last chance, right? I forgot to do that. Should I use that? Change. Hold on. So maybe all of that. Hold on, let me see what that gives. Not great. Not great. Man, for sure, I gotta slow it down. So this is going through all the things. Oh wait, this should be the slot. And 6Js, thank you very much for the follow. This is not a good look. So I'm iterating through if it's our last chance to mark it. And that thing is, oh, this part needs to go. We don't care if it's 0. Man. A reek in the house. What's happening? When we getting food? You tell me, man. I'm ready. Hold on. We're still not there, but it's getting closer. So if we're at the last chance to mark this slot and we haven't marked it, and we have enough free seconds, then we should mark it. I gotta do some debugging in this thing. Oh no, that's hard to read. Oh wait, 6Js, sorry I missed your message. What level challenge is this problem? This is from the contest that just went by. This is the Q3. Let me look it up on zerotrac to see what, because I struggled on this problem. I'm just trying to like upsolve it. So I guess zerotrac doesn't even mark it yet because it's so new. Man, should I give up? Because I'm struggling too much. 0, 1. me look. 7. So I guess we won't even mark anything here unless wait, every time you say that 20 push-ups, man, I've been struggling, man. What are you talking about? How do you do last night? I had to bounce. You mean the contest? Straight rogue? I didn't do too great. Be more like a reek. Never start in the first place. Nah. Hold up, hold up. How am I gonna find the problem here? So this is 8. So I go all the way up to 8. So last chance. Oh, maybe I want to do that too. So that's my 3 seconds. Maybe let's do... Keep on keeping on. Get some inspiration from Pat's Hello World. Yeah, actually I do get a lot of inspiration from his channel. Rodrigo Paradav, thank you very much for the follow. Seven and 1. All right, so this is like last chance is 666. We're not there yet. Oh, we're here, right here. Oh, we're here, right there too. 4. So we should have 4 free seconds. Oh, snap. What was that? Index 4. 0, 1, 2, 3, 4. That's the 3. So we should be able to mark that 3 as seen. Right? Why are you subtracting num slot plus 1? I'm trying to figure out how many free seconds I've had up until that time. So the plus 1 is for the actual marking of the thing. And the slot, the num slot is the value of the nums at that slot. And then the plus 1 is for the marking. So here, all right, here is the 8 run, which should be okay. So at 4, we marked slot 2, and then we marked slot 1, but we haven't marked slot 0. We should have marked that right there. But maybe we don't have enough free seconds or something. So why? Man, this is a struggle today. That's for sure. So 1, 2, 1, 2, 1, 2. So the 0 never gets marked. Slot 0, which should be at 7, right? So when we guess 8, we should get up to that index, and we do. It's right here. But the problem is we don't have enough free seconds to market, man. Where's all my seconds going? So I marked 2. That costs 1 second. This is an off by 1 problem, maybe. I don't know. Or something. Down for type racer? We just did one not too long ago. Alright. I don't know what to do here. Somebody gotta help me out. One, two. Let's scroll up and read the code. Alright, here we are. I have a lot of C outs here. So I'm trying to count how many free seconds we've accumulated. And then if it's our last chance and we haven't marked it and we have enough free seconds to mark it, then we should mark it. Oh man, is it because... Hold on. Think I should do... Oops. Think I should just increment my free seconds anyways somewhere before I do all this junk. Let me try that. Maybe that was it. Hold on. Let me get rid of these dang things. Man. Finally. I see where I made the bug. I wasn't treating these slots as a dang free second. Alright. Too easy. Wait, type racer? Wait, did somebody redeem a type racer? And I missed it? I was too in the zone. Now do part 2? Yeah, right, man. You know, I didn't even read part 2 on the contest. I was like, nah. Oh, he wanted to. Should I redeem that? I'll give you all a free type racer right now. How about that? Who's here for type racer? There's 81 rings. Hope you're still around. Free type racer. Alright, y'all ready for it? Who should I race? I don't know yet. YouTube people, are you here for type racer? What's going on, YouTube? Let me create a racetrack. Well, first let me throw up a bet. Should we do a rerun no condom, Chris, or what? You think is 14 too much? Should we do like 12 WPMs? I'm gonna do no. Wait, 14 seems okay. Alright, let's do it. It's gonna be a rematch. Midnight Simon plus 14 WPM's handicap is gonna be faster or equal to no condom Chris. Place your bets. You have 2 minutes to decide. Put those bets down. We're about to type race. Dang, no condom Chris coming up with 12,000 bucks just like that. Q Ultimus also throwing down 5K. If y'all want to make some money, maybe I can make you some money right now. Alright, here's a type racer. First race is a warm-up, second race is a championship round. And let me not forget the YouTube folks. Y'all can join too if there's anyone out there. All right, warm up round. Here we go. Get in here. Oh, Arik is in here, man. It's gonna get spicy. Man, 117. Arik with a 122 and Guest with a 123. Who's that Guest? From the USA. We'll never know. Man, that's a speedy race right there. I'm Guest. Oh man, 81 rings is tearing it up. I thought you had an account. 81 rings. You gotta log in, man. All you guests out there should log in for maximum fun. Need an account? Yeah, you should have been had one. All right, championship race is about to begin. Serious business out here. No joking around. Oh man, it's kind of long. I fumbled at the end, but still got it. Dang, Arik with the 121. Very nice speed. Not surprised. No Quantum Chris with the 100 WPMs. I'm coming in with 93, but the bet was 14 WPMs. So, dang, this is a bumping racetrack today. Let me put it up. Let me put it up there. So, no Quantum Chris is going broke on the streets today, man. Because I got a 14 WPM handicap. Maybe we'll bring that down next time. Jesus, Clistar, Arik, Wise Sane, big bucks, Mortimer, Jims, Slawcat, William Fonseca, Straight Rogue, Lead Coach. Thank you very much. I'll take it out on Pat. Oh no. Daniel Luna. I need one of those keyboards. They sound good. Yeah, this is a bubble 75 with Aqua Kings switches. Alright, that's it for the type racer. Time to get back to the leak coding. Time to work out ASAP. Man, I have to say, Pat has really inspired me to like do more. You know, I feel like I should be doing some of those exercises with him, man. Maybe I'll start doing it while I'm watching. He's gonna work out 60 days straight, man. Maybe I should tune in, man. Slawcat, have a good night. I'm not gonna do it on stream, man, but maybe I should do it off stream. You'd have a pull-up bar in the side cam view. I mean this view, my pull-up bar like right here or something. Yeah, in Rosis, maybe I should, but I probably can't even do that many pull-ups. It's been a while. Hold up. We gotta do some zero tracks. That's what we gotta do right now. I've only done one dang problem today. So, all right, we'll make a bet. Random number between 17 and 1800. That's what we're going to bet on. And then I'm going to do that problem. 2 problems? What do you mean 2 problems? So here's the bet. High or low? 1 minute to decide. Oh, you did the daily and Q3. Yeah, the daily doesn't really count though when it's easy. So you have 1 minute to decide. I'm about to roll these dice. 1700 to 1800. What is it going to be? Is it going to be 17 to 1750? Or 1751 to 1800? Man, nobody wants to bet. We're rolling dice, yeah. This is how NFL got record profits this year? What do you mean? Just by pushing up bets? Simon looking kind of fine today. Thank you, 81 rings. Thank you for your kind words. All right, place your bets. We're about to roll these dice. Dice. Dang. SM123, what are you doing, man? You coming in here, you just dropping 25K like that? Come on, man. Oops. It's a typo. All right. Well, you better hope it doesn't go bad. Here we go. 1767, man. You got lucky. So you're about to go broke. All right, it's gonna be 1767. Let's go. Man, congratulations, SM. That was a bold bet you did. Q Ultimus, No Condom Chris, back from the streets. Asia C Mac, Straight Rogue 16. Congrats. All right, 17. All right, the closest one is this Throne Inheritance, or sum of matrix after queries. Did I win? Nah, Icy Black Deep, you didn't win, man. You lost 30 bucks. Yeah, you're on the streets. All right, Jesus Christ. I don't want to read all that. All right, I'm gonna opt to do this other one instead. They're both the same rating, but this one is a lot less reading. Sum of matrix after queries. You're given an integer n and a 0 index 2D array queries where queries I is the type, index, and value. Initially, there is a 0 index n by n matrix filled with zeros for each query. You must apply one of the following changes. If the type is 0, set the values in the row with index to val, overwriting any previous values. If the type is 1, set the values in the column with index to val, overwriting any previous values. Return the sum of integers in the matrix after all queries are applied. Mad Thad 91. How you doing? Welcome. Joining, the first thing I hear is you're on the streets. Yeah, lots of people just went on the streets, man. They just gambled the house away. All right. What are we gonna do? What are we gonna do here? How do we get this sum, man? All right, so they say we have an n by n matrix filled with zeros initially. Let me draw that out. So example 1. There it is. Zeroed out matrix. And then these are our queries. So we got 4 queries, and they're telling us the queries are structured like this. Zero Sade, thank you very much for the follow. So this is type 0, type 1. So if it's a type 0, we're doing the row at index. At type 1, we're doing the column at index with that value. Okay, so I guess our sum is 0. So first query is a type 0 at so we want to set 0. Man, how are we gonna do this? How many queries do you have? So, okay. So I'm thinking we can't do an n squared traversal at the end to just sum the matrix up, because the matrix is too large. That's 10,000 by 10,000. That will probably be too large. So then we need some way to know. Maybe I need like a rows and a column sum. Mad queries, big ass matrix plus mad queries, yeah. What streets? Man, the streets. The only streets. So this one they say fill row 0 with 1s. So maybe instead of having a sum, I can have like row the sum. And then this is saying fill column 2 with 2s. But now the columns. So then when we fill column 2 with 2s, what do we do? So this would be 6. I guess we can just replace this value outright. That would be 6. But then this row 0, how do I know that row 0 was previously a 1? Do I just check that cell? Do I check the 1 cell in the type? And then I just add the delta there. So this would be 4. And then here they give us row 2. Fill it with 3s. Oh, but all these rows have like Man, that's a lot of queries, man. That's like 50,000 queries. Brett in the house. How are you doing, Brett? This one is fun. This one is interesting so far. I too enjoyed this one, man. Did everyone, was this recently or something? Alright, anyways, row 2, fill it with 3s. So that should be 9. But column man, how do I know that column 2? How do I know that column 2 just got? Well, all these columns need to be updated. Hold on. So this column needs to be added a delta of 3. So column 0 gets 4. This column... Man, we can't... If I did this one by one, I think that would be too slow. I think that would TLE. Because of like 10,000 by 10,000. So I need to figure out some way to do this faster, man. Like this column 1 would also get a delta of 3, so that was 4. And then this one would get a delta of 1, column 2, so that would just be 7. And then the whole row here gets replaced with value times n. You'd be correct. LeetCode in a nutshell. So how can we update these without Pot Feet, thank you very much for the follow. I'm thinking, do we necessarily care about all the queries? Or do we just care about ones that actually change a cell that leaves its mark forever? I don't know if I can easily calculate which of these queries are relevant. Can I ask about the contest questions now? Yeah, you can ask about them for sure. Hold on. I don't know what to do here. And then this one is saying at column 1, wait, column 0, fill it with 4s. So they're saying 4, 4, 4. And 4 times 3 is 12. But then all those other values changed. For Q3 was the answer to sort change indices. No, Q3 was tough, man. I did binary search. I can share my solution with you, Steven Saggy Ball. But it was a real struggle for me. I needed a lot of help from chat, from all of you. How can I share this? Sum of matrix after queries. Have I ever solved this? I don't think so, man. I wonder if Do the queries, they're applied in order, right? I wonder if the order, maybe we can go from backwards, like the final queries first. And then once we've seen those cells, like we never see them again, maybe. That. Let me start over on example 1, but instead of going through the queries from index 0 to the last index, I'm going backwards from right to left. And then as soon as something is seen, I won't ever change the value of that again, right? So, all right, we're at this query. We want the column 0, all 4s, and we've not seen any of these. So 4, 4, 4, and our sum is 12. Then we go to the next one, and it's row 2, fill it with 3s, and we go to row 2. But we've already seen the first index, so we don't even touch it. Then we go fill these with 3s, 3, 3. And then that adds 6 to our sum. And then we hit this one, type 1. So column 2, fill it with 2s. Column 2, 2 and 2. And then that adds 4 because we don't touch that since it's already seen. That's 22. And then the last one, row 0, fill it with 1s, and we only add 1, 23. I don't know how to solve this, but I think you're onto it. Chance Dies, welcome to the party. Chefing up a tasty dish. I think so, man. I think this seems reasonable. Let me see if I can implement that though. Maybe we can use Boolean to mark the thing as seen. And then we go from, we have n queries. So we want to go from the right side to the left side. And then I'm gonna just type these things out so it's easier for me to read. So, all right, if it's a type 0, that's a row. How do we do that? We go from the column 0 to the end, and we just mark, oh, I guess we have to check if seen index C, continue. And then we mark it as seen, and then maybe we need to remember like how much we're adding here. right? And then we can also say if the column no, that's all we need to do, right? Let me think. Yeah, I think that's all we got to do. And then we do the same thing for the column, except I guess this can be R. Is that it? Will that work? If we've seen everything, should we just exit? Do we care about that? Let me see. All right. Not right, not right. That's because we already have an N. All right, let's see. Looking okay so far. Time limit exceeded. Come on, man. All right, maybe it's so close. Maybe there's some slight optimizations I can make to make this pass. Let me think about that for a second. Gotta put some more spices. Yeah. Sinbleed, what's happening? With a interview today with Apple for kernel dev, I was able to implement Linux kernel ring buffer in C live with interview. Awesome experience. That sounds pretty fancy, man. I don't know what a Linux kernel ring buffer is, but it sounds crazy. I think there's a worst case bad stuff if a row never gets touched. Ring buffer is like a poor man's deck. Circular linked list with mutex locks. I see. Kind of. All right, let me think about how can I optimize this a little bit more. If a row never gets touched. Man, I was just looking at my solution. I was writing some clean ass code back in the day. Are you not writing clean ass code anymore, man? What can I do? How can I speed this up? I think. So maybe, all right, the only the last thing matters for a cell. So I'm guessing time exceeds on which test case a big thing. I don't have any great ideas immediately. I gotta really think here. How can we stop? Maybe these for loops are not that great. So I wonder if I have some ideas, but I think it would be like overly complicated. I'm wondering if we can have these column 0 to the end as variables, and like if we've seen the ends, we don't need to start at the ends. We can just start at like the first unseen thing. But how do I know what is the first unseen thing? Maybe I can do some weird, I don't know. Man, I hate when I spend a ton of time on a solution to get to a problem only to realize it won't exactly work as I'm thinking. Anyone has strategies to check if a solution may or may not work early on? This way I don't spend a ton of time on it. Depends on, I think if you want to know if it will time limit exceed, you can do some quick calculations based on the constraints to figure out if it's too slow. But if you want to know that your idea is just gonna work, yeah, maybe it's just like you gotta solve more problems. So time limit exceeds. Maybe. All right, I'm thinking I can do some. No. I'm gonna say maybe I can just mark a whole column or row. Like without iterating through the thing n times. But how would I mark a whole row as seen? Do I need another seen rows and seen columns? And I can just check like if I've seen that row or column, the whole thing, I shouldn't even go there. I don't know, man. I'm feeling like, should I read a hint? What kind of optimizations can I do? Anything input constraint above the size of 10 to the 5th or 10 to the 6th? Is that kind of DP or memoized solution or binary search? What? I don't know about that, man. I mean, a DP could be bad time complexity, or it could be okay. If you want a hint, I don't think n squared can ever pass this problem. Yeah, I realize that now. But so need an ON. You're doing OQ times N, which is worse. It is worse. You need prefix sum. Initially, I was thinking prefix sum when I first saw the problem, but maybe not 2D prefix sum. Maybe there's... I don't know. Alright, so we start from the back. Man, I'm kind of stumped. So maybe we keep track of the sums of each row and column. What can we do? What can we do, man? I wonder if I should just completely erase everything. For sure, I need to get at least rid of these 4 loops here, but I don't know how I'd replace them. Not sure. If this is the difficulty, I'm more moving towards segment tree approach because it has n queries. I don't even know segment trees, and I don't think this is a segment tree problem. This is, yeah. It's a Q3. I am stumped. I'm not gonna lie. I don't have any more spices left. Should I look at topics? Hash table. Hash table. All right. I think maybe I have some ideas. So maybe all right, I'm thinking maybe I don't know how to articulate my thoughts yet. But when I read hash table, some ideas popped up into my head, kind of dealing with this kind of stuff. So maybe like once we mark a row, we need to figure out like how many unique rows and columns that we've seen. So if we've seen 5 unique rows, the first column that we get to, and we know that we've seen 5 of those things, that means the sum that we add is n times the value minus the number of rows times the value, because we're not going to change all those numbers, right? And then I don't know if that works though. Let me try and code up what I'm thinking. So should this be a set? All right, so this is a row. So that's if the whole row was unseen, but we've already seen some of these columns, so we got to subtract that. That's what I'm thinking. I don't know if this is correct though. Should I see? No. Wait. Close. Is it? Nah. This doesn't work because I don't know why. Oh, wait. It doesn't work because, first of all, that's wrong. Let me see if it works now. Man. Something ain't right, but it wouldn't. I think it must be close, right? Because that's a lot of dang test cases that it passed. But it's incorrect, man. I don't know what to do here. Should I just... Man, can I say it? Should I just give up? 20 push-ups, yeah. Oh, man. So I'm thinking like, why would this not work? Is it a problem with my logic, or is it a problem with my implementation? That's what's going through my mind right now. Tap it and dump it. What's up? How long you work on a problem before giving up and looking at the answer? Usually within an hour, if I'm to be honest. But if I feel like it's within range, like it's within my skill set or my skill level, maybe I'll like just peek at a hint or something. Usually I like to look at the topics as a hint first before I read the actual hints. And if I feel like I'm making progress and making observations, then I'm less likely to just look at the answer. But if I'm absolutely stuck with no ideas whatsoever, then maybe I'll just look. Bad to give up on problems like this because you are very likely to retain it if you can solve it. Never give up? I don't know. I think you should give up sometimes, man. Alright, never surrender? I don't know. I don't know. So, do you think maybe, can I overflow here? 10,000 times 100,000. What's that? Is that overflow territory? Maybe. Should I have these as like longs? Is that one E9? I don't think it's overflowing. But just to double check, man. Yeah. It might be. I don't think it's overflowing because this number is larger than the expected number. So if it was overflowing, I mean, it could potentially overflow, but I don't think this particular case is failing because of an overflow. Right? Is there some a long? Yeah, it's a long for sure. Tap it and dump it. Thank you very much for the follow. Alright, man. I think it's time for me to give up. Spent too much time on this one. It's gotten a lot of test cases passed, but this particular test case, my number is way too big. You're very close, pretty close. Alright, is it a bug or is it a flaw in the logic, or is it just there's something else I need to consider? Maybe that type of hint is good. The shower is a good place to think about your unsolved problems. Yeah, I think about my problems in the shower, in bed, on the train, stuff like that. Still going? Yeah, I am still going, man. I usually do this for about 3 hours whenever I stream. So let me think what's actually happening here. So I'm trying to remember how many unique rows or columns that I've seen. What is the edge case in this test case, man? That's what I'm trying to figure out. So if I am to change a full row, you do offline? Nah. The only, yeah, I'd say 99% of my studying LeetCode is online, like on stream. So if I hit one row, and when I change a column, man, the problem is I think my logic is right. I can't see the flaw, but clearly there's something wrong, you know? What's line 31? It's like if we've seen too much, we should just quit. You think maybe that's the bug? Huh. Interesting. My answer changed, which I don't think it should have changed. Because once we've seen everything, so that means I'm updating things that I shouldn't have updated. I don't know, man. I'm French Baguette. Hello. What's happening, Ragnarok? Ragnok? How you doing? I don't know. What's do Q? Is this formula wrong? The number of rows that we've seen. That should be the number of things that we're changing. Oh, wait. I think I seen it. Come on, man. Come on, man. What a silly bug. So my logic was flawless. My implementation was terrible. That's all there is to it, man. That's all there is to it. Oh yeah, let me check both y'all solutions. All right, I'll check Q's first since he posted it first. Man, it's the same thing. It is the same thing. Except you don't even need to know which ones are seen. I guess you can just increment there or something. Which is kind of like the value of this vector anyways, so maybe it's a bit redundant. But nice. Let me see what BetSimp did. Dang, look at that. What the hell is this, man? Done. I'm not sure what this is. Do you know about the tabooness of vector bool? Man, I've read about this a ton, but I don't really know like why it's such a big deal. I mean, anytime I read it, I understand why it's a big deal, but anytime I try to remember, I don't remember what the big deal was, you know? Can't take references. Huh. Interesting. It doesn't work the way you expect sometimes. That's the big deal. It's optimized by packing the bools. I think I've read about this at least 3 times in my life. And I still don't know. Like off the top of my head at least. But I do know there's a problem with vector bools. Anytime I use a vector bool like this, I'm always thinking, man, should I be doing this right now? Or I don't think it matters for LeetCode that much, right? They store 64 bools, so you can't take a reference of an individual bool. What do you mean? You mean like they're doing some bit masking stuff or whatever? Where they use an integer to represent all those bools? Yes, bits. I see. Right. Yeah. I think I understand why you can't do that. Alright, man. That problem was tough. I'm not gonna lie. That problem took a lot of thinking, a lot of like trial and error for me. It was tricky. How can you get the memory address of a single bit? You'd be splitting the atom. Let me think about that, man. Oh, so if each memory address is a 64-bit chunk, going Oppenheimer. Yeah, I guess I don't really know much about like all that super low level stuff. I don't know how the memory addresses are formed or like how granular those addresses can be. Like if the 64-bit chunk is as granular as it gets. Yeah, I don't know anything like that. Should I do one more problem? What do y'all think? Or what? I got to? Yeah, I know. I should. Gotta get back the ratings this weekend. Yeah, I know, man. I've been slipping. Basically we have like vector type, then the black sheep vector bool, which is a whole other piece of work entirely. I use vector int. So what I understood from this is you must start using Rust. Nah, I'm good. I'm good on that for now at least. All right, let's do another problem. I guess we'll take, should we do like a hard problem? 1917. That's some WW1 type of problem. Ooh, we got 3 choices. Which one of these 3 should I try? Q4s? Q3s? Robo Dom in the house. What's happening, Robo Dom? How you doing? Might have done weekly contest 379. Probably one of the first 2. Alright, let's try. Ooh, dang. Let's try this middle one, man. Oh, already done did it. When did I do that one? A year ago. Robodom, thank you very much for that hydrate. Cheers. Oh, I did it 2 years ago, almost. Some rage submissions there. Nah, those aren't rage. But man, I did it a lot more optimal. Why Danush? Hello there, welcome to the party from YouTube. Alright, maybe I'll try this one. Make cost of paths equal in a binary tree. Can you do this even more optimally now? I guess we'll never find out, man, because I'm gonna try this one instead. You're given an integer n representing the number of nodes in a perfect binary tree consisting of nodes numbered from 1 to n. The root of the tree is node 1, and each node I in the tree has 2 children, where the left child is node 2 times I, and the right child is 2 times I plus 1. Each node in the tree also has a cost represented by a given 0-indexed integer array cost of size n, where cost I is the cost of the node I plus 1. You are allowed to increment the cost of any node by 1 any number of times. Return the minimum number of increments you need to make the cost of paths from root to each leaf node equal. Note, a perfect binary tree is a tree where each node except the leaf node has exactly 2 children. The cost of a path is the sum of costs of the nodes in the path. I won't stay consistent in solving LeetCode problems, but I will try for a 20-minute and I watch a solution, and after 2-3 days I forget how I solved it. Well, the key is you gotta keep trying those problems. Those problems that you couldn't solve, you need to go back like a week later and keep drilling them. You can't just watch the solution and go about your business. I think you really need to struggle to like truly remember how to do it, you know? So I think all you got to do is just stick to your training schedule, man. Set aside like 10, 15, 20 hours a week, maybe even 40 hours a week if you're that serious. And just make sure you're always studying, you know? Always doing new problems or always doing like relevant problems, I guess. Doesn't necessarily have to be new if you can't solve them, you know. Doesn't make sense to try new problems if you can't solve half the problems you already went through. Gato More GM, what's happening? Welcome to the party. Someone can give me a hands-on Python training. I study HTML by Free Code Camp tutorial project, but doesn't exist a Python tutorial there. I don't know where to go for Python, but there's a ton of resources online probably. I think there's one course by Angela Yu that I see recommended a lot online. Let me see. And Angela Yu, but it's a paid 100 days of code Python thing. I see lots of people talking about this one, but if you don't have, I don't think you should pay $100. It goes on sale for like $10 all the time. But there's one. If not, maybe there's free resources out there. I'm not too familiar with Python. Amit Coder, what's happening? Thank you for lurking. Well, this is a good start for free. Thank you, Tap It and Dump It. I've been thinking about learning Python. Rovodom, you should check it out, man. Al Swigart has a Twitch channel, or the person who wrote that book. All right, we got a YouTube comment. Thank you. By the way, I want to know what tech stack you work on in your job. I do C++. Basically, C++, almost everything at work. All right. What are we doing? We're doing this problem here. This binary tree problem. So 10 to the 5th nodes. The minimum cost. Let's look at this example. So we have 7 nodes. And these are all the costs. Oh, Ryan from YouTube says, I got to 50% completion on Angela's course. And after that, I decided to start a data structures and algorithms course and been trying... Man, how did I get rid of that heart? Trying to improve each day. Ryan, you sound like you are on the path to righteousness, man. You are about to get all these LeetCode problems. Vinci G, welcome to the party. Over time, I stopped watching tutorials and refer to the docs first. Push through the getting started guide no matter how hard. And if I don't understand it by the end, a simple YouTube vid works for me since I have the knowledge already primed in my head. That is, yeah, I also don't really do too many YouTube videos or anything. I also go straight to the official documentation. And that's been okay for the most part, I think. All right, let me think about this dang problem. So they don't actually give us the thing. They don't give us the binary tree. They give us these this array, and we have to figure out like which path the things are on. Yeah, Ryan from YouTube says, "Is this hard?" Yeah, this problem is not too easy, man. Don't get scared. But if it's probably like if you're just beginning, I'd say these problems are way too hard for beginners. You need to work your way up. That's why I use this website, zerotrac. Here, I'll link it in the YouTube. I'll link it in the Twitch chat. But it basically ranks all the problems, and I think you start off with a 1500 rating if you don't take any contests. But once you take contests, maybe after like 5 or 10 contests, you'll see your rating, and then you should do problems around your rating level. So right now my rating is like in the 1900s. So I try to aim for problems in the 1900 to 2K range, and those should be challenging for me, which they are. Like this problem is for sure challenging. Dysel 26, welcome to the party, man. Different things works for different people. Personally, plural site paid has been a great resource for learning. Typically, I search for fundamental courses. Once I have the fundamentals, I experiment, but also follow docs. Nice. Thank you for sharing. Any opinions on HackerRank? I have no opinions on HackerRank because I have never really used it. Okay, so I guess we can figure out which nodes things are, because these are the indices, and if we draw them, or let me put the one index indices, 1 2 3 4 5 6 7. So like I guess it would kind of look like that. Strike on, bro. Welcome to the party. So 1 5. Let me do some math there. This path is 8. The next one is 9. The next one is 6, and the last one is 4. So this 8. Should I just draw it? That's 8. That's 9. That's 6. And that's 4. And then they're saying the answer is 6. Because I guess we can add 1 here. No. Increment the cost. All right, yeah, so we add 1 at this node here, right? And then node 3. Oh, we need to bring these up. So these are both 9 right now. And then we got to bring this one up. And And then that one too. Basically, right? Bobby Dubs 1, welcome to the party. Is this Java? Nah, this is C++. Don't you worry. You're not dumb, man. I didn't even have anything on the screen except this thing up here. So I think maybe what I have to do is... So we can only go up, we can't go down. So maybe I can separate these things into each level like I did here. And then I suppose we want every level to be equal. Alright, I think I can solve this. So I'm going to use a vector thing to represent my tree. And then I already have n. And then maybe I know how many per level. So the first one would be 1. So I think these, actually maybe I'll do like, these are powers of 2. Are you learning, or how long have you been coding? So I am learning. I'm always learning. I've been coding for about 10 years. And I still struggle a lot too, man. I'm in school for computer science right now and I have been struggling. Don't you worry. I think struggling is a part of this job. Usually binary trees means recursive functions, no? Yeah, usually I'd say that's common, but this one they don't actually give you the tree. They only give you the nodes in an array. So you have to know, like, I'm trying to like know how many per level. So how do I do this? If I don't know what I'm doing, but I think I can do this, man. So I'm trying to like separate this array into all the different levels of the binary tree. So the first level will have 2 to the 0 elements, which is 1 element. The second row will have 2 to the 1 elements, which is 2. And the next row will have 2 to the 2 elements, which is 4 elements. So I'm trying to like put all these numbers in a thing. And then I'm going to do something. I was thinking to just make every level the same number, but I don't know if that's a good strategy. I think that's not gonna work actually. Let me think a little bit more, man. What about iterative DFS? Who does that, man? They give you the tree. That's how you represent a perfect binary tree. All right, I suppose they give you the tree, but it's not in the traditional tree node type of thing. I guess we could do recursion there, but I still don't know how to solve the problem. You need to know how many levels or divide the array into a binary tree. So maybe I should see what each path ends up. Yeah, you get the left and right child by doing, yeah. I seen that now that you said that they give you the tree. But so I think this example, it turns out that the answer is just to like make all the levels equal, right? But I don't know if that's true for every binary tree. Like, let me try and mess with these numbers a bit. Like, what if this was 0 and this is 3, right? So in this path would be 4. This path would be 4. And let's say those were 0. So this would be 3 here and 3 here. So the answer to this would be 2, because we can just add one node there, one here and one there, right? So I don't know what to do, man. Because I was thinking if we can just make every level equal, but that's not the optimal solution. That is far from optimal. So how do I go from here to... What if I start from 3, 3, 0, 0? Let me think. 3, 3, 0, 0. And then we got 3, 3. I'm just going up, up. 0 plus 2 is 2. Plus 2 is 2. And then now maybe I go like 1, 1. So this would be like 4, 4. Three, 3. Is that 0, 2 plus 1? If I went that way, then I can just find the max and get the mins here. Mogul Codes, thank you very much. Oh man, these aren't Xylants, these are Aqua Kings. Brett, what's happening? Let's start at the root. What is the largest sum root to leaf? I was thinking of going from the leaves to the root just now. Like how many, like figure out how many leaf nodes I have, and then just figure out like doing something. But all right, let me follow your guidance. Also, pets, hello world, what's happening? Welcome to the party. All right, so let's start at the root. This is the original problem that they gave us. So this one is 8. Wait, let me. 1 plus 5, 6 plus 2, 8. This one is 9. This one is 1 plus 2, 3 plus 3, 6. And this one is 4. So these are sums. Yeah, so we need to make all paths 9. That is correct, because we can only increment values. So we got to make all paths 9. Hepta 5, what's happened? CRM stunk, go up. Very nice, man. I'm jelly. So starting at the root, we know the largest path from the root is 9. Now suppose you go right. Google stock is poopy. Yeah. Wait, suppose you go right. What do you mean suppose you go right? Starting at the root, we know the largest path from the root. Oh. What's the largest path from the... Oh, it's 6. Right. So this is the largest path. On that side. Let me try and think. Oh, suppose we treat node number 3 as the root of a subtree. Right, so he's saying the largest path from here will be 2 and 3, 5. Yeah, and we have 1 from the parent. I'm missing a 3? Wait. Increment node 3? I'm missing a 3. So we should increment node 3 because... Oh, we need 3 more to get 9. I see. Not missing a 3. So we increment node 3 by 3. So instead of being 2, this would be 5 instead. Wait, what? That sounds crazy. If we increment this by 3, man, like... Oh yeah, 1 plus 5 plus 3 is 9. So now that's equal to 9. I think I see what you're saying, Brett. But that is a little bit crazy to think of, like, on my own. Basically, what is the most you increment node 3 by while not making any root bigger than 9? Yeah, I see what you're saying. Since it's a perfect binary tree, don't you just have to break it apart from the bottom and recurse? You start at start and end index and break the middle and recurse down until you reach root? So I was thinking, all right, before you gave me those ideas, Brett, I was thinking of somehow finding the leaf nodes in my thing here. I suppose the leaf nodes would just be the last however many things, right? And then I guess find like iterating over. So I'd go there, then I'm gonna go to here, but now I'm going to add, so I have like 2, 3, 3, 1, these nodes, and then when I move to the next level up, we're gonna have 2 numbers, 5 and 2. So then I'll take the first half and I'll add 5, so this becomes 7. This becomes 8, and then 2 to this side, so this one becomes 5, and this one becomes 3, and then we go up 1 more level, and then I just add 1 to everything, so that would be 8, 9, 6, 4, and then I remember the max, and then I just like do the math here. This is what I was thinking for my solution, but will that work? It seems like it should work. But this is equivalent to incrementing every leaf? I don't think so, because we don't increment the leaves. So we only start incrementing once we go all the way up to the roots, right? So like these are the leaf nodes at the bottom here. But every time we go up, we're like accumulating its parent nodes. And then we only do the incrementing once we've added the root node to all the paths. Is it the same? Oh yeah, yeah. I see, I see. It is the same. Yeah. So maybe my idea is terrible, huh? Is it? Let me see. 1, 3. Yeah. That's too many increments. All right. So this idea is completely wrong. But that's where my mind was going right before you came out here. What program are writing in C++? I'm just doing LeetCode problems in C++ here. Okay, so all right, let's try and implement what Brett was trying to explain to me. So we need to find the largest path. And then once we get that path, Solo Rush 1010 from YouTube. Thank you very much for subscribing. I don't have any YouTube alerts set up yet. Which level you're solving? Here's a problem. I'll link it here. I'll link it in Twitch also. This is a medium, but it's a rated 1917 medium, which is hardish medium. All right, let me erase this. Let's apply it to Amazon. I don't know about that, man. All right, so let me just make a DFS. So if we're out of bounds, man, how do we do this? What kind of emotes are those, man? All right, so if we're out of bounds, we do something. Oh, maybe we want like, man, how do we know when we're at the leaf node? I guess. So maybe I'll do that. That's my current path. And then I want to go left and I want to go right. I guess this could be a void because I'm not actually going to use those return values right now. So DFS. But these need to be one indexed. So should I just add one? Should I just minus one there? So that's left. And then plus one is right. So this should get me my maximum path. Should we test it? Are the numbers negative? No. So DFS costs, I'm gonna start at 1. And then our current path, I guess, is 0. Grill Coder, thank you very much for the follow. Let's see if this is gonna work. Is it true you work at Bumble, Robodom? What? Is that true? All right, max path is 9. All right, so now let's make another DFS or something. DFS 2. So we need like our parents. Man, that is... So we need our... Not just our direct parent, but all sums above. Right? Alright, so if we're out of bounds... Nah, I did it here again. Man, it's time to go. I just looked at the time and I gotta go. But I'm gonna try and finish this real quick. So this one can be an int because we need to return something. Katsu009, thank you very much for the follow. What's the sum above? So then we're saying if the sum above plus the sum below the max below so if that plus that is less than we need our target. If that's less than our target, then then we need to add that. Frackery, thank you very much. Right? And then what do we return? We want to return the sum. What do we return, man? Cost I plus max below, I think. Man, that if this works, which no doubt in my mind it works since Brett guided me. But man, how am I supposed to think about this solution? So we hit that, then we hit the DFS2. Costs start from 1. What's our parameter? Sum above, answer, and target. Sum above, the answer, and our target. Let's see. Cost, I, sum above, and target. Nah, could not implement correctly. Why is that? Why is that? This should be... So the max below 0, 0, above and below. If it's less, oh, above and below, and the current value, I think. Current value. I don't know where I messed up, but I think I gotta go, man. Five more minutes. I think for sure we need this here. So we had 1, 3, 4, 5, 6, 7, 8. Yeah, so we need this. But I'm still not sure where I'm messing up. Sum above plus the current value, right? Answer by reference, yes. Target doesn't change ever. The amount below needs, oh snap. Oh yeah. I see what you're saying. Nah, wait. So the amount below needs should account for how much you add at the current node. So that, I mean, I think it's worth resuming next time. Yeah, maybe it's getting kind of late. But let me see real quick. So I'm only adding, where am I adding? I'm only adding at node 6? That doesn't seem correct, man. It seems... Alright, let's see. Above. Below. Alright, after this, I gotta go for real. Above 7. below 0. Is that right? Oh, wait. How? Oh, snaps. Above is 7. How is that 7 at node 6? And node 3 above is 5. Oh man, am I having off by 1 issues with my index or something? Should this be -1, -1, -1, -1? Oh, maybe. All right, for node 6 above 3. Oh, yeah, I see. I see what's happening, man. But I think, yeah, I think it's time for me to give up because it's past my bedtime. But when I send things down, how do I know that I've added something? I think that's where it's messing up because I'm sending the sum above, but it doesn't include if I added something to it. So it's like double adding for sure. And I'm not sure how to deal with that yet. But anyways, I gotta go, man. Maybe we'll try it again next time. Thank you very much, Brett, for helping me out. Supplied Orange. Howdy. Goodbye also. Yeah, who's streaming? Zombie Chow, what's happening? Pat's Hello World. You already know where we're going, man. We're going to Pat's Hello World. Big inspiration. All right, thank you for tuning in, everyone. Oh, snap. Oh, Omkar. I just saw your message, my bad. I've also started my data structure algorithm preparation. Is there any suggestions to code like me? Man, I've done tons of practice. I think I've studied for around 2,000 hours. And that's my suggestion, is to make it a habit, keep practicing, keep studying, and you won't get better if you're not practicing. Anyways, Q Ultimus, No Condom Chris, Robodom. Have a good night. Brett, Zombie Chow, Lead Coach, Supplied Orange. Have a good night. Daiso26. See you later. Frackery. Hepta5. Have a good night. Moogle Codes. Good night. Bobby Dubs 1. Everybody. Kamza, have a good night. YouTube, all you YouTube people, take care. Thank you for tuning in. I think my YouTube thing is going great, even though I haven't uploaded any YouTube videos. But thank you all for subscribing and watching. and all that stuff. Adios, amigos.